Toby here with Touristic Technologies, and there we go. Snoopy University. Anyway, just still playing around with PLC Next Engineer, and I thought I would talk about some basic timers, that kind of thing. So if we take a look at timers in relationship to PLC Next, that's me. Anyway, they got basic timers like everybody else, which we have the TON, which the way that I think about that is I'm setting the time it takes. So your input, which would be your coil that is on your ladder that is going to initiate your timer, or it's going to be whatever binary input that you have to the function block, and then the preset time, and that's represented here. But like I'm saying, we do a coil, whatever action that is going on here, button, response, whatever. It's going to be this start input, and then you're going to have your time here, which, whatever seconds or whatever. And then in this case, it's going to be a Q. In Rockwell case, you'll have the timer timing, the timer on, you get like 4 variables. You don't get that here. And I'll show you in a minute. So let's get out of this for a second. So if we go to the next one, and why won't it do it? I don't know. There we go. Now I'm going back and forth. Well, let's just start over. So TOF is the other one. How's this for organization? Alright, so timer off delay, and I think about that one as I'm delaying the point at which it's done. So if I cook dinner and I don't want to serve it for 2 minutes until it sits on the stove and then cools off a little bit, then that's kind of like your timer off delay, because the action was occurring and we finished. As far as your input, that's what you got going on here. So your input goes high, and then it stops. It waits this preset time, and the output from the timer is on from the time that you get it to that preset time. So the difference is here. So your input goes high, goes low. The timer stays on after this is turned off. So an example of that would be, if I open the garage door, if I have a garage door and it's closed and I drive up to it, then I want it to open, and I want it to stay open long enough for me to drive in, and then give me X amount of time over here before it closes again. So that's kind of the way I think about a TOF. The other thing that we have in PLC Next technology is a timed pulse, and in that instance, you get this double action going on. So one application is the Christmas tree that I did. I can show you that. And then what I have loaded on the PLC right now is not that. I tried to make a garage, which is kind of silly, but I did it anyway because it's the middle of winter in Iowa and there's nothing else to do. So I took this from my Christmas tree one, and I'm still using the kit that Phoenix Contact sent me, and just going through some functionality here. So you can see my networks here for my garage door, and what I'm going to do is simulate, and this is my garage, and I'm going to simulate that the car came, or that a car comes. Let's see. Alright, so we'll turn it on. Alright, so right now I've got number 4 is already on, which means that it's already gone through its cycle. So at this point, my car is in the garage. So I'm going to turn this off. Alright. And reset it. So if we turn it back on again, then my car shows up. My car's at the garage. My car door opens, or not my car door, my garage door opens, and I do X amount of time to let my car go in, and then my door closes. That's what I was trying to show you a minute ago. So and if we'll just reset it again, and let's see if you can do. Alright, so there's my garage door. These are my inputs over here. I want to see the timers go. Because as you can see, I did a TON and I did a pulse, and that's a TON with a reset. On my other example, I have a TOF, and this is what I was talking about as far as the inputs, the cues, the estimated time, and then the time that you actually input. So, alright, so right now I'm going to reset this, turn on light 4, which is going to be triggering my car. So my car pulls up, triggers the pulse, 10 seconds, the garage door goes up, and you see it change here and here, and then the car goes in the garage and the garage door comes down. So it's just a way of playing around with timers and working with the HMI. Because I noticed the other day when I was doing stuff with the HMI that if I used the blinking in the HMI, then it slowed down my computer quite a bit. If I caused blinking to occur with a timer, then it seems to go easier. So if I go offline, I can show you where that goes. Also, this is just an image that I brought in, and you can dump it. Let's see, HMI. Yeah, so you have a local drive here, so if you go, like if I just want to add an HMI image, I can pull it up from the computer and dump it onto the PLC. Did that from the internet. So you could make your HMIs pretty fancy there. The setting here are the dynamics. I'm just having it go black when the garage open is true. And then when it goes back to false, then it shows the door on the front. I am moving the car when I call it turn it on the ho-ho. It's from my Christmas tree example, because I just copied and pasted and got lazy. So what I'm doing in this instance, I'm using this bit, turning on the car coming in, and then putting in X amount of time, and then when this goes, I will open the garage door, and I give myself X, X amount of time for the garage door to open. Once the garage door is open, and actually I'm turning on the ho-ho here, so simulating with this bit that the car is pulling up, turning on the ho-ho, saying that there's a car at the door, and then once this timer goes off, that car's been there X amount of time. That's what you see here. Then it will open the garage, and then you can toggle this image based on the bit saying garage open. So anyway, let's see if we do. I know you'll be bored to death with the Christmas tree, but I'm gonna pull it up anyway, because the other day when I used it with the blinking function, it went really slow, and I got it a bit more organized now. And what I mean by that is, like, if I click here, I can make it blink. Each of these balls I can make blink based on the HMI computer, or my computer, but the HMI runtime, and that seemed to make it worse than actually having to go through a timer as far as coming on and off. So it runs smoother the way it is now. And let's see if it will. When I tried to do this a minute ago, it errored out. Alright, so the build was successful. I am dropping it into the PLC. It's asking me to log in again. And you can simulate from the PLC, from inside PLC, the PLC Next Engineer, as far as, like, if you want to launch the HMI simulator. I like to just go ahead and get online with the PLC, because then that way I can split my screen and see what's going on. And yeah, it's preference, I guess. Seems easier to me. Alright, so at this point, I don't have any inputs on. You just heard me turn the one off. That's gray there so that I can see it. But just to give you an idea, same thing, just using basic networks. I use the pulse here for the words coming across, and then I use the TOF for turning the lights off. As I said, the difference is when this state changes here and it says to turn it off, it's still going to wait a little bit for other things to occur, or for a little timing. So the set of lights associated with turn off lights 1 will go off, wait a little bit, and then turn off lights 2. I grouped them. That way I didn't have to write out a bunch of code. I initiate it with the star. Turning on the star once the star is on. As long as my lights 1 set is off, then it will go again based on whether or not I turn on the physical switch to turn on lights 1 and 2. And then we're going to time that. Once that's on, and then it will turn on the 4 associated with lights 1. Lights 2 is if lights 3 isn't on and lights 2 isn't being asked to turn off, turn on lights 2. Once the timer goes through with that, it'll toggle again, but it'll turn on the 4 associated with lights 2, and then lights 3 up hit associated with lights 1. And alright, so we can see the current state that it's in when I don't have any physical switches turned. And if I go over to the variable page, you can see that as well. So I'm not turning on the star or any of the lights. So we're going to turn on the star we'll see that come on, which you see the true. And then you see the bit saying that the star actually turned on. So the timing already went through. And if I turn that off and I go here, you can see the star is on. And the tree is, I don't know, warming up. So, all right, I'm going to do the next set of lights, which is 1, which would be 1, 3, and these guys. And that's just based on the bits. And as you notice, you got to turn on the troubleshooting function for it to show you in runtime what's going on. And you can see it turned on the star. It went through its timer. Star had to be on for lights 1 to come on, and that has happened. And we're not in a toggle state yet because we don't have lights 2 on. So I'm going to flip the switch for lights 2, which you just saw it go. So now we will start a toggle state, if you would. Maybe, I think I have to get one more and turn on the next one. Is she gonna start toggling? She might, there she goes. And then ho 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 comes on. So we should be able to see all 3 of the states here for the most part. Which that's state 3, state 1, state 2, so that's 1, 2, 3, and then back to 2, back to 1, or back to 1 and back to 2. And I'm calling it states. Essentially, you can turn it into a state machine from here. I didn't do it pretty. This is just me goofing off, so I haven't done a quote-unquote spreadsheet and all that stuff that we're supposed to do. My whole intention was just to see how the triggered timer went, and the TOF and the TON, make sure that I understood that they're behaving the same way as what I'd expect, like coming from Rockwell. So if I lengthen this a bit, which can do fairly easy like that, let's see what, I think the ho-ho will stay on longer. Yeah, so that just makes the pulse longer. So if you picture, it's turning on there, it's timing, and it's high for the pulse. It's high the whole time that it's pulsing, and then it goes off and comes back. So, and like with any other kind of sequence, you can play with the timing and speed things up or slow things down. Or like, oh, look, it killed the star. So will it work now? It will work partially. But I don't think it will cycle the way it was. Because lights 2 has to go on and off, or lights 1 has to get on and off to toggle 3. So right now we're kind of stuck because the star's not on. So if I turn the star back on, there's a timer to start the star, but you saw the ho-ho come up right away. So, and then we're back to 1, and that should do 2, and then it should do 3. And the ho-ho comes on with the 3. So Anyway, just playing with timers and getting more familiar with PLC Next. Check it out. Talk to your Phoenix contact person. They will be more than happy to help you. Have a good night.